Hi, my name is Alexia Block. This is Psychological Foundations. This is November 22nd, and this is my experiment summary for my signature assessment. In this experiment, I will test students on their ability to think with abstract reasoning and use logical deduction to solve a hypothetical scenario. So Jean Piaget's fourth stage of cognitive development, the formal operational stage, describes children 11 or 12 years or older to be able to think abstractly and logically to solve problems independently. At this age, the child has formed their own moral compass and should be able to solve hypothetical issues as well as real-world problems. Students will independently be presented with a prompt that has the scenario as stated. Design an experiment to test if plants grow faster in the sunlight or darkness. Provide your prior knowledge of plants and your hypothesis statement based on what you already know, including experiment controls, variables, and the procedure for your experiment. Students should be able to write a clear experiment description for this hypothetical situation based on their prior knowledge of photosynthesis and their skills of how to set up an experiment. In this stage of their cognitive development, my ninth grade students should be able to set up this experiment with ease and critically think through problem solving. I will be observing their written responses as well as analyzing the guided instruction and will have them to lead them to their own conclusions based on their experiment designs. I do feel that them working on their experiment design independently will give me more of an insight into their development and what stage they actually are in. But in ninth grade, all the students should be in the formal operational stage. So when we do the experiment, we will see. Okay, class, so today we are going to be designing an experiment to test if plants grow faster in sunlight or in darkness. If you would look at the smartboard, this is the equation for photosynthesis. That just means that this is how photosynthesis sustains itself, or how plants sustain themselves, and how they maintain their glucose. You know, plants, they feed themselves, so this is photosynthesis and how they do that. So you take carbon dioxide and water. It is facilitated by light. What does facilitated mean? Does that mean like help it, maybe? Yeah? Okay. So it's facilitated by light. It makes the glucose, the sugar that the plants need, and then it gives oxygen off as a product. Which side of the equation is our reactants? Do you remember? It's going to be our left side. The left side is our reactants, and the right side is our product. So the product is the result. This all happens because of sunlight. Okay? So in order to design an experiment to determine if plants grow faster in sunlight or in darkness, we need to know a few things about what an experiment means. So, first of all, we know the question. Do plants grow faster in sunlight or darkness? In order to design the experiment, you first need a hypothesis. What do you think will happen? Well, we already know that plants grow better in sunlight, right? But we have to test this. So I want you to design an experiment to test how we're going to determine if plants grow faster in sunlight or darkness. Okay? In your groups, I want you to first write your hypothesis. Then I want you to design the experiment. Okay? Does anybody have any questions before we go on? No? You all ready? So, what is your experiment design for your group? What have y'all decided that y'all are going to do? You can say put a plant in a closet, perhaps. That's dark. It has to be complete darkness for it to be in the dark. So where's a place that you could put a plant that is complete darkness? Yeah, in a closet, close the door. Yeah, just a dark room. Well, you'll have to pick one or two of those for your experiment design. Okay, y'all picked your closet, so that's your darkness. So you're gonna write dark test, and then your place of choice for the darkness. Okay, we're gonna go to this group. So for your experiment design, what kind of way are y'all gonna test the light? How light affects a plant? Yes, put it outside in daylight. So that's what you'll write. You'll put light test and outside in daylight, if that's what y'all pick, okay? And you, what is gonna be your control? How are you gonna decide which one is in between? What's in between direct sunlight and absolute darkness? You remember that word I talked about? How about indirect sunlight? Where is a place that we can get indirect sunlight? In a classroom. In a classroom. So what you're going to write is control indirect sunlight in a classroom. That's what you're going to write on your paper for your experiment design. Okay? Okay, this is my experiment results. So originally this experiment was originally designed to evaluate if students could design an experiment which would indicate if they were in the formal operational stage of Piaget's stages of cognitive development. In this explanation of the objective for the students that I did, I noticed that while I was doing that, students had a little understanding of how to design an experiment due to their lack of understanding of what the experiment consisted of. For example, I did have to tell them that the experiment needed a hypothesis and you needed to determine what the independent variable of the experiment was, what the control would be, etc. So I did have to include an explanation of what the experiment needed. Furthermore, when the students were asked how they would design their experiments, most of the students did not fully grasp what they were supposed to do, as if they were almost unable of grasping the deep thinking skill that they needed to design the experiment. That led me to believe that most of the students are not actually in the formal operational stage of development, but really I think they are mostly in concrete operational stage of development, that they have not yet reached formal operational stage, meaning that they're able to induce logic or draw conclusions from their own experiences. From what they know, they're able to understand, but they can't think deeper than what they have experienced yet. And it was kind of shocking to me because Piaget's stages of cognitive development, they do have age groups, and the age group that they fit in is not their actual age. So the age group that they are supposed to be in is 11 and up, and that's the formal operational stage. But actually, most of them are not quite there. So, they're not able to solve a problem by drawing conclusions quite yet. That also includes designing an experiment about photosynthesis and how to see whether you would test, or how you would test if it grows better in darkness or in light, and they just were not able to do that on their own. I had to lead them and guide them a little more than I expected. In this case, the photosynthesis part that they did not understand was a 5th grade science standard, and really, honestly, I think that they were not taught that. From my knowledge of these students and what they were taught. I don't think they were taught this. I will also say that once the students were given leading questions and some guidance, they were able to go forth with their own experiment design and be able to tell me what the control was, what their experiment consisted of, but they still needed help getting started. More help than I had originally anticipated. And their actual experiment designs were accurate. After the fact, they were accurate, and they would all be able to test whether plants grow better in darkness or in light based on their experiment designs, and I was really proud of that.